Hi, what's up? How's it going? First thing is first, please read the description because anything that I wish I would have said at the beginning of this video, I'm just going to write in the description because I never know what I'm going to say. And I never know what I wish the preface was. So, yeah. Welcome to unscripted, unscheduled, organized chaos and the usual disclaimer of this is not high dopamine content. So, grab your cup of tea. I've got mine. And we just hang out. The thing I want to talk about today is that I got one of those apps where it's supposed to help you stop scrolling so much. Which one doesn't matter, right? But there's like a few that are being marketed right now that essentially, instead of mindlessly scrolling through reels on Instagram, shorts on YouTube, instead they give you little doses of information about things you're curious about, topics and themes spanning things like logic, math, literature, art, whatever you want, right? Well, no, some of them are limited, some of them have more. But the point is, I got one of these subscriptions just for a month to try it out. And I started the math course because I find that one most interesting. And you know what? I'm actually surprised, but there's something I learned from the very, very, very beginning lessons, which included just addition, subtraction, multiplication, division, and it was about fractions. Because in my head, I have a sort of imagination of every single math concept or topic or theme. If I understand it to some extent, then there's some sort of imagination or image that comes along with it. And the one I have for fractions is the cross multiplication, which is usually what they teach us in school. And the one for cross multiplication in my head is the image of an X. So imagine we have two fractions. One of them has a different denominator than the other. So let's choose two at random. Let's say 1 over 7 and 2 over 9. So we have two fractions, 1 over 7 and 2 over 9. I kind of want to write this down for myself just in case, so I can see what I'm talking about. All right, random page in the notebook. 1 over 7, 2 over 9. Perfect. So whenever we go about comparing fractions and when we go about trying to answer, are these two fractions the same, or which one's bigger, or which one's smaller? One of the best ways that we're taught to do this is to translate them into being the same denominator. And of course, you can also think about it in terms of percentages or something else, but not the point right now. We think about it in terms of cross multiplication. When we want to change or translate fractions into the same denominator. So if we have 1 over 7 and 2 over 9, the way I would think about it is I would have this arrow going up in which the 9 is being multiplied by the 1, and I would have a second arrow going up diagonally the other way in which I'd have the 7 multiplying by the 2. And so I would just get that answer. So like 9 times 1 is 9 and 7 times 2 is 14. So in that case, it's really clear to see that 14 is bigger than 9. So that means 2 over 9 is a bigger number than 1 over 7. But it does get confusing when it's just the diagonal crisscrossy things, because it doesn't feel very stable. Like, it's just very crisscrossy. And I realized that the cross multiplication of just one number, like of the denominator to the opposite numerator, is the same thing as multiplying by 1. That's in essence what we're doing. So we take the 1 over 7, what we're really doing is we're multiplying it by 9 over 9, which is equal to 1. we're not just multiplying the numerator by 9, we're also multiplying the denominator by 9. And same for the other fraction, when we have 2 over 9, we're not just multiplying the numerator by 7, we're multiplying 2 by 7 and 9 by 7. We're multiplying 2 over 9 by 7 over 7, which is equal to 1. I don't know how long ago I did fractions that I forgot this whole essence of it, which is essentially that we're multiplying by 1, and we're multiplying both the numerator and the denominator at the same time. It's not just a crisscrossy situation of cross multiplication. I don't have to imagine it in my head as cross multiplication. I can just imagine it as taking the numerator of one fraction, making it into its one, like it over itself, which is 1, right? So like 9 over 9, 7 over 7. And multiplying the existing fraction by that entire second fraction, which is 1. I don't have to imagine it with the crisscross. Like, that's so interesting to me that I completely forgot that this is how it works. And so it's easier now. So then, like, if you ask me, like, is 1 over 7 bigger than 2 over 9? Now I can train myself and I'll be like, okay, well, 1 over 7 times 9 over 9 is 9 over something, right? What's 9 times 7? It's 36, right? And then 2 over 9, well, what's that times 7 over 7? 14 over 36, right? And so we don't need the denominator if we're just answering the question of which one's bigger, because 14 is bigger than 9. We get it. And so that's the answer. We don't need the denominator written there. But the thing is, it's not just gone when you do the cross multiplication. Like, it's still there, right? Like, how did we get that 9 and that 14? Well, because that denominator has changed from 7 and 9 to 36 for both of them. It didn't disappear. It's still there. And we're essentially just translating it, one fraction into another, and it means the same thing. But fractions are very interesting because I'm using the word translation, but I don't know if that's really accurate. Like, we use the word translation, right, when we're talking about translating from one language to another language. And also when we're translating between different units. So I guess translation really means when one thing equals something else, just in a different context or different units, but like they're equal. Like, it's just a different word, but it's the same thing type thing. So in one sense, translation does work as the word for this scenario, because like 1 over 7 is the same thing as 7 over 36. But it's only the same thing in terms of percentage. It's not actually the same exact fraction because we're using different numbers. And the reason I say it's not actually the same fraction, well, it might not matter that much at the moment when we're talking about 1 over 7 and 7 over 36. But it could matter when we're doing other things like limits and calculus, right? The limits that come with the whole field of calculus and derivatives and integrals, because suddenly, even though fractions might equal each other, if there's a term in the denominator that the original fraction becomes undefined, like x minus 1, where x, like at x equals 1, if the denominator says x minus 1, we get a 0 in the denominator and we can't solve it. And so then it becomes important that even though we can translate the fraction into another version and make it mean almost the same thing, there are still cases where that translation will still have like an exception, right? So for the fraction that has a denominator of x minus 1. Well, you can't solve it when x equals 1. Even if, like, let's say the numerator was also x minus 1 over x minus 1, right? Because that's the same thing as 7 over 7. 7 over 7 is equal to 1. If we have a fraction that's x minus 1 over x minus 1, well, that's just equal to 1. But also it's not, because that actual fraction, like if that was a function where we had x minus 1 over x minus 1, if that was how it was originally defined, then it would be undefined at x equals 1. Speaking of undefined, why? What is up with the whole we can't divide by 0? Like, I get that we can't divide by 0. I understand that we can't do that. But I don't maybe can't we ever come up with some rule or definition or a new type of math where we can divide by 0? Because like every single new math, right, comes with a question of, well, what if you could do this? Or what if this was the answer? What if this was the case? So for example, right, let's think about addition, and let's say 2 plus 2 equals 4, right? Those are our current rules. And for example, 12 plus 1 equals 13, right? But then what if someone asks the question, well, what if 12 plus 1 didn't equal 13? What if 12 plus 1 equaled 1? Then what? Then you have clock arithmetic, which you have 12 numbers on a clock, and you add one more hour, you get to 1 o'clock, right? And you could change that base from 12 to 3 to something else. But someone asked the question, like, well, what if the things that we know, what if it was a different answer? So, is there another example that I have of this off the top of my head? Oh, geometry, right? So like in regular geometry, I forget, what is the original? Euclidean geometry, right? In regular geometry, we have a square and each of the angles are equal to 90 degrees. What if someone went and asked, well, what if the angles didn't equal to 90 degrees? What if we still had a square? By our other definitions of a square, I don't know, which is like, the same length of every side. But what if the angles weren't 90? Where could that be a thing? New math. Spherical geometry but on a sphere. Now we still have a square, more or less, but the angles are not 90 degrees, or triangle angles, or someone said, there's the shortest distance between 2 points is a single line. Someone was like, well, what if it wasn't? What if there wasn't one shortest path? What if there was more than one? Taxicab geometry. There you go, right? So we take the things we know and we ask the question of, well, what if it wasn't like that? In what context is it not like that? Because all of math can be added to, and all of math can be expanded upon and made more abstract, and new fields can be created. Math and our notations are all up to our imagination. So, given the examples, back to the original question. What if we made a notation in which it was possible to divide by 0, in which dividing by 0 wasn't undefined? What would it be? How would it look like? I don't know. Let me think about this for a moment. So, the number 0 is more of a placeholder than it is an actual quantity. So most of our numbers represent physical quantities. At least that's how it began, right? So 1, 2, 3, 4, 5, the counting numbers and up, or like 1.5, or you can have half an apple, you can have a quarter of an apple. And yeah, all of these were physical quantities related to the physical world. But math itself is not bound by the physical world. So then we have the concept of zero, the concept of infinity, all the other concepts, because all of the mathematical objects are imaginary and they're in our mind. You're not going to find a perfect circle, in the world, or a perfect square. We have shapes that look like circles and spheres and squares, but none of them are perfect circles because they're all made out of atoms and everything's vibrating. Nothing's like perfectly on a perfect circle. Point is, zero, right? And then the negative numbers. Before I get to zero, the negative numbers, they are not really quantities either, are they? They're just the way that we define like subtraction, more or less, or the opposite of the counting numbers. That's kind of what they are. They are the opposite. But in order to have an opposite, we need a zero, right? Because you couldn't have 1 plus minus 1 equals 0 if there was no zero. So 0 is not a quantity. It's kind of like the neutral state. Yes? No? Maybe? Let me think about this. So, what do we have? We have like you can't hold 0 of something. Well, actually, 0 kind of is a placeholder at the same time, because it means there's nothing there, but it means there's a place for something to be. Because nothing and 0 somethings isn't the same thing. Right? So like, for my computer science people out there, you know that, NA, not applicable, versus 0, like blank and 0 are not the same thing, right? If something is blank, that means there's no data. If something is 0, it's 0, but 0 is data. So maybe it's about the place. Because 0, like I was just saying, 0 implies that there is a place for something to be, and that it has none of those some things. And blank means we don't know what's happening or anything. We don't have any information. And so, if 0 is the place, then dividing by 0, it makes sense that we don't understand the concept of dividing by 0, that I don't, because how can you divide by nothing, right? Like, if I have 2 pencils and 2 people, I each give them 1 pencil. If I have no pencils and 2 people, I can't divide something I don't have. But can I divide by the place? Like, I can answer what I would need that 0 to be, right? In order to give each person 1 pencil. Like, if I had 0 pencils and 3 people, I couldn't divide the 0 pencils by 3 people, but I could say that, well, there's this space and it's missing, and what it's missing based on the number of people I have is 3. It's missing a 3 because I have 3 people, so I need 3 pencils if I want to give each of them 1 pencil. You can't divide by 0. Oh, I'm thinking about this wrong. I'm dividing the pencils by the people. If I have 3 pencils and 0 people, no people, then what? I just have 3 pencils? But am I not the place in this scenario? Like I am the place, right? No, that doesn't make sense. Wait, maybe it does. Okay, hold on. So, I have 3 pencils. If I have 3 people, I divide my 3 pencils by the 3 people. I give each of them 1 pencil. So, great. 3 divided by 3 is 1. I have 3 pencils. There are 0 people. So I have 3 pencils. There is 1 person. So that means I take my 3 pencils divided by 1. So I hand all my 3 pencils over to the other person. So they get 3 pencils, because 3 divided by 1 is 3. I have 3 pencils. There are 0 people. That means I have 3 pencils. That means no one else has pencils, because there's no other people to give the pencils to. But that means I have 3 pencils still. Do you see what I'm trying to say? Like, in the scenario where I divide up the pencils by 3 people, 3 pencils and 3 people, I get left with 0 pencils. And I divide them all up to the people that are there. And I'm not counting myself. And when I have 1 person, I give that person all 3 pencils. And I'm not counting myself. Oh, so then why do I start counting myself when we have 0 people? Then there's just 3 pencils and 0 people. But the 3 pencils still exist, even if there's 0 people. Right? So why? Okay. Based on this, I would vote for attempting to figure out a math where dividing by 0 is the same thing as dividing by 1. The 3 pencils still exist, just no one has it. So they're not divided. Dividing by 0 means you're not dividing it. Dividing by 1 means you're not dividing it. So, I would just vote for we try it out as a math where dividing by 0 is not undefined. It is defined, and that definition is, well, what if it's the same as dividing by 1? And that's one example, because we could also try a different way, where currently the way we have chosen is just to say it's undefined. We could also say it's 0, But logically, I don't see where that conclusion would come from. That dividing by 0 is 0. Because if we had 3 pencils, they still exist. We don't magically have 0 pencils just because we have 0 people to give it to. Unless we are talking about, the double split experiment in physics, where physics more or less shows that when something is perceived, it changes. That observation changes the results. Or maybe that wasn't the double split experiment. Maybe that was the entanglement at a distance particles, spooky action at a distance, as Einstein called it, where we have 2 particles that are entangled and they spin in different directions. And if they are entangled, then no matter how far apart you take the 2 particles, if one, you keep them in a box, right? And as soon as you open one box, the other one is automatically, no matter how far apart, spins in the opposite direction. And it is the observation that makes it so. I don't know. No. Am I wrong? That might be one example of it, or it might be Schrodinger's cat, where there's a cat in a box that's either dead or alive, and it's both at the same time. Until you observe it, then it's only one of them, because you don't know what's there. So what if dividing by 0, if there's no one to observe the pencils, do they exist? We're getting into some sort of philosophy train of thought right now. How did I get here? I don't know. Maybe I do. It wasn't that many tangents, I don't think. So we have okay, so in most of the scenarios that I was explaining, where we have 3 people and I have 3 pencils, or we have 1 person and I have 3 pencils, or we have 0 people and I have 3 pencils, I am the observer. I am the observer in those scenarios, but also I'm not. Had to pause for a second, talk to someone. Anyway, back to the question. So, we have me as the observer, right? But I wasn't counting myself in the actual math of the problem, because if I was, then there wouldn't be 3 people to divide the pencils by. There would be 4, because I would be included. And then there wouldn't be 1 person to divide the pencils by. There would be 2, because I would be included. And then in the 0 scenario, there wouldn't be 0, there would be 1, because I would be included as the observer. And I would have all the pencils. And if there were no observers, then how do we know the pencils are there? Do we care to know that the pencils... Well, even with mathematical objects, right? Even with mathematical objects, the second we think of them, they exist. That's why some of the most powerful words in mathematics are there exists or let there be. That's how every single proof starts. We create the objects, we say that they exist, and then we do whatever we do. Whatever formulas, or work with them, whatever. Prove whatever we prove. So if I say there are 3 pencils, I am automatically placing myself in the position of the observer, that I am observing that there are 3 pencils. Imaginary, real, whatever. Like even imaginary, that I say there are 3 pencils. Because if I take myself out, then how do we know if anything's there? 3 pencils, not 3 pencils. Like what? Like if no one and nothing is there, and I'm not the one saying there are 3 pencils. Like if no one is observing the 3 pencils. Like what? There's nothing to divide then, right? Like to divide by 0, I see how we got to labeling the divide by 0 as undefined, because you can't define it, because you don't know what's happening there. Like you have no idea because no one's observing it. Like the 3 pencils exist or don't exist, we don't even know if there's no one there. So that's why it's undefined, because you can't divide something because no one is even there to even know if that something is there. There's nothing to divide it by. And you also can't say it exists because there's no observer, because the one is the observer. That doesn't mean we can't define it a different way and still try out the math of where we say dividing by 0 is equal to the same thing as, the number itself. Like we can still try it that way. But yeah, I'm just working through the thought process and thinking about it. I mean, maybe there's, okay. You know how, what I was saying before is that different maths have different contexts. So in our context, the most common one, dividing by 0 is undefined. We don't know what happens. It doesn't make sense. Maybe there is a context where, in fact, dividing by 0 is equal to 1, or is equal to 0, or is equal to the original quantity. Like maybe there's a context or a math which assumes the observer as separate than the quantity. Like I was doing in the scenario where I was saying that I have 3 pencils, there's 3 people, I divide the pencils by 3, I get 0. I'm still existing as the observer. I get 0 pencils, and I give 1 pencil to each person. But I still exist. And so in all these scenarios, we're still assuming an observer. But it's also sort of a transfer of quantities, because I get 0, they each get 1. We have 4 people, 1 gets 0. So if there's an imaginary plus 1 at the end of every single numerator, there could be a mathematical world like that. At the end of every single numerator, it's not, or denominator. No, numerator. No, well, I'm confusing myself again. So if we put the plus 1 in the numerator, then we're still dividing by 0 and it doesn't make sense. But if we're putting the plus 1 in the denominator, then maybe that's what I'm talking about, because or maybe it has to be outside of the equation. Okay, so if there's 3 people and there's me and there's 3 pencils, and I have 3 pencils, then if we add a plus 1, so I'm taking 3 divided by 3 is what I'm doing. No, adding the plus 1 doesn't, I don't know where the plus 1 goes. Because I was going to say if I divided, 3 divided by 0, and there's 0 people, there's still me. So then I would add the 1 to the denominator, and I'd be like, okay, well, it's actually 3 divided by 1 because I'm still the observer that exists. It's just outside of, maybe it's 3 divided by 1 plus 3 divided by whatever. It's 3 divided by 1 being transitioned into 3 divided by whatever X number of people there are besides me. That if the X is greater than 1, then I end up with 0. Well, not necessarily if the X is greater than 1. Just if the X is anything besides 0, like if it's a positive number that's not 0, then I end up with less pencils. So we're also subtracting from me. And division is technically repeated subtraction. So like, I would give 1 pencil to one person, like person A, so that would be the same thing as me subtracting 1 pencil from me. I'd give another pencil to person B, I'd give another pencil to person C, so then I'd subtract 1, I'd subtract 1. So like if there was a 0, right, then there's nothing to subtract, but that means that I have the quantity still. Okay. I think I'm good on this thought for now. I think my conclusion is maybe I'll sit down and try to see what math looks like when dividing by 0 equals 0, or when dividing by 0 equals 1, or when dividing by 0 equals the original quantity that we had, which is like when dividing by 0 equals the same thing as if dividing by 1. But there is that distinction, right? Dividing by 0 versus dividing by 1. The observer, like the quantity remains with the observer when you're dividing by 0, if we're assuming the observer isn't being counted among the division, versus when we're dividing by 1, the quantity gets transferred from the observer to another person. So the quantity remains the same, but it remains in either the observer's hands or another person's hands. That's the difference between 0 and 1. Because if there has to be an observer, because if there's no observer, how do we even know there's a 0? That's the point. Blank is not the same thing as 0. So if there's an observer, I guess what I'm saying is that if we make dividing by 0 the same thing as dividing by 1, what we're essentially saying is that the observer and another person are like equal, is what we're saying. That it's the same person. Because otherwise there has to be some sort of change, because there is a change. The pencils go from me to someone else that's not me, because I'm not in 2 places at once. Unless I'm like light, which is both a particle and a wave at the same time. Or maybe just, anyway. It has the properties of both particles and waves at the same time. So I'm not in 2 places at once. So something has to happen. There has to be some difference in this world. the value remains the same, but it's a different quantity or characteristic that changes. It's not the quantity that changes. There's another additional characteristic, and it has something to do with the observer and another third person person. I don't know, another person. Okay, so essentially in this case, I would just make a new notation that would include the information specifically about the observer. And whether or not the quantity remains with the observer or some people, something outside of the observer. Yeah, okay, I'm tired. I think that's good of a rabbit hole or whatever I was just thinking about for today. Anyway, that's how new math gets created. And that means that we can create new math, and maybe it's not as hard as it seems. Also, one of my friends and I are actually using the same ideas to create a new math where we asked a different question. We're like, well, like, what if this exists and this exists? Let's say we, create this variable and this variable and this position and this position, and then what happens? We're doing that, and I find it really fun, and I hope I can share more of that at some point. About the particular math that my friend and I are making. But I think I might have just thought of another interesting avenue for another thing to explore. Maybe someone's already thought about this. If there's a math that already exists about this and you know it, let me know, because I'm curious. Or maybe I'm just, completely going into the philosophical things and less math things. But also you can't really separate math from philosophy. Not really. Anyway, this was fun. Thanks for hanging out. See ya.